Hi, I'm Lori Sweeney, and I'm going to give you a mini math lesson. First is geometry, and the second is a mini lesson in algebra. I'm going to pretend that a class got the quizzes back and there was one area that some had trouble with. So I will be going over that material to make sure it is mastered. So when the test comes up, they have it and it's simple. So we are going to start our geometry lesson. And I am going to share the screen with you. So we are going to talk about area and circumference of circles. So the area is the measure of space or the region inside the circle. It is the total number of square units inside the circle. So remember when we had our rectangle and we had to find out the area. And remember that was what class? Length times width, right? So we had 12 times 4, and that was 48. And remember we had meters times meters. We multiply the units and we treat them like they are variables. So remember when we multiply the exponents, what do? We add them, right? So we have m squared. So it's going to be 48 meters squared. So there you go. So I'm gonna make sure you could read that. And of course, I will be asking more questions for the class, and to answer, I will be more engaging, but this is just a video presentation. So you can see it's squared units, and units can be square feet, square inches, square miles, square yards, square centimeters. So as area is squared for a rectangle, it is also in square units. So remember, air for area, air is squared. So we're going to find out the formula for the area of the circle. Now, I had trouble deciphering between area and circumference when I was younger, so I came up with some cool ways to remember. They're silly, but you will remember them. So I'm going to see if any of you guys recognize this character. I'm sure everyone's jumping up. It's Patrick from SpongeBob. Yes, that is right. And Patrick is going to help us learn the area of a circle. Now, remember, Patrick, is he one of the wiser characters on SpongeBob? No, he's kind of silly in his beliefs and things he thinks. So keep that in mind. And here's Patrick saying, A, pies are square. And we say, no, silly, they're mostly round, they're mostly circular in shape. So how does that tie into the area formula? Here it is, A pies are square, which is this, A pies are square. So you see that, that is a good way to remember it. So let's understand what everything means. So R is your radius. That is the point from the center of the circle to a point on the circle, to any point on the circle. So it starts from the center and it radiates out and it goes to a point on the other side. So here we go, it radiates here and it radiates to a point that is on the circle. And there, we could draw many, many radii. So plural is radii. Of course, we would stop at the circle. It's a little tough to draw on this, but I think you get the picture. So again, here are radii. And again, it starts from the center and it goes to a point that is on the circle. And then pi, this is pi, and that represents, well, it's a mathematical constant. It's the ratio of the circle's circumference to its diameter, and its value is 3.14, or you can even say it is equal to 22/7. Pi actually goes on forever, but we could cut it off at 3.14. Sometimes I will ask you for values for area in terms of pi, and sometimes I will ask you to use 3.14 and come up with a numerical answer. You got to be careful because sometimes they do not give the radius, they give the diameter. And the diameter is a chord. A chord starts at one point from one side of the circle to a point on another side of the circle, and it can be various lengths, and and it can even go diagonal from here to here, let's say, or here to here. The chords go from one point from one side circle to one point on the other. So the diameter is actually its longest chord because it is from one point here to one point here, and that is in the center of the circle. So if you're given the diameter, remember radius starts at the center and radiates out to a point on the side of the circle. So this is your radius, and your radius we can say is equal to 1/2 of your diameter. Okay, so keep that in mind. We can't just grab numbers and just throw them in. Have to know which is which. So what do we use the area of a circle for? It's nice we calculate it, but we sometimes need to find the area of a painted design. We need to find the area of a design to know how much cloth is needed or felt, something along those lines. How big a gazebo is for parties or for a band to play. They need to know how much space they have to work off of. The surface area of a pool, how big is the pool, the swimming area of it. And sometimes we need to determine how many cans of paint are needed to paint a circular design, or to even paint a round table. Sometimes cans of paint will say this can be used to paint this many square feet of, let's say, a wall or of some object. So it's important to know how many square feet we have so we know how many cans of paint to use. So let's try some examples. What is the area? And we're going to say in terms of pi. We'll just leave it as pi. We will not multiply by 3.14. So when you do any kind of problem, it's always great to write the formula down. So remember, Patrick said A, pi's are square. And now we just plug in the value. So A is what we're trying to find. And then we have equals. And the pi is just our constant, that's our pi. But remember, our radius is 5. So we have 5 feet. And then remember, we have this squared. So when we report area, it's always the number, the pi, and then the units come at the end. So when I square this, this is going to be 5 squared. This is going to be 25. And then we have pi, and then we have the feet squared, because everything gets squared in those parentheses. So remember, you have the number, and then the pi, and then the units. So let's take a look at this. So I'm going to do it. All right, so I have, let's see, 12. Oh yeah, pi r squared. So we got pi and 12. So, okay, that's 144. Okay, there we go, I'm done. Oh, and I forgot, I got pi 144. It's pi 144. And then I would ask class, what's wrong with that? And they will tell me the various things that are wrong. And there's a lot wrong with that, believe me. So we didn't even write the formula down. And that is important because that could have helped us with some of the errors that we see here. So what we have is, okay, here's the area, and then we have the pi, but now we're looking for r. What we see here is this r. No, so we just grabbed numbers and we threw it in. And it's important because on these standardized tests like SAT and ACT, they trick you that way. So you can't always just grab the numbers and put it in. Your answer will be there in the multiple choice, but it will be wrong. So remember, we're talking radius, which is half the diameter. So that will be 6. So now we have, and also we didn't have units here, did we? So this is wrong for so many reasons. So now we have our 6. So we have 6 centimeters. And then remember, we're squaring that. So let's put our number here. We have 36. And then we have pi. And then we have centimeters squared. And that's our answer. And then what we will do is we would do a word problem and learn how much we would have to pay for mirror glass, but we need to find the area. For circumference, it is the distance around the circle. So it's very difficult to take a ruler and try to measure it will not happen. We can use a tape measure or something like that, but it can be a little tricky, especially with circles that are not so rigid. So what we can do is use the formula, and I have a cool way of remembering that formula. And take a look at that. Here are 2 pi's, and I'm going to tell you, see, you see that? See, 2 pi's are mine. See, so where does that fall into play? C, get it? C, 2 pi's. So here's our 2 pi's are, see, and that goes with this, 2 pi's are goes with that, and then mine just finishes the sentence. So C, 2 pi's are mine. And then that's a lot of fun. So we have our units. It can be in feet, inches, miles, yards. Notice it's not squared because we're not multiplying. Just like in our perimeter, we were adding up the sides and getting a value. Well, that's the same for this. When you have a perimeter, you're just finding the total length. And in this case of the circle going around. So we want to make sure we remember that. And what do we use circumference for? We can find the distance around the track. A lot of times in parks, they have these tracks with lanes, and it reads in this lane, you will run 1 full lap is equal to, let's say, this many yards or this many feet or this many miles. And it also is helpful to find circumference or perimeter, right, of the circle, to put a fence around a circular pool and to find the distance a tire will travel after a certain number of revolutions or rotations. And this is really cool to find the diameter of a tree, because some people, so you would use a tape measure to find the circumference of the trunk, and then you could plug it into the formula and find the radius and then the diameter, and you can find out year to year how much that trunk has grown. And it's really, really neat to see. So we would try some examples, and in this case, it would be about a circular fence, and we would find out how much fencing we need to put around that pool. So now I'm going to do the algebra portion. A lot of students mess up on the 0 power. So I will say, class, on your recent quiz, I did see a lot of people put anything to the 0 power 0, and they put 0 in there for their answers. But remember, anything to the 0 power is 1. And let's understand why. Remember, anything divided by itself is 1. 5 divided by 5 is 1. 3 divided by 3 is 1. 9 divided by 9 is 1. So anything divided by itself is 1. So remember, when we divide exponents, let's connect the two, keeping this in mind about anything divided by itself is 1. When we divide, we subtract if the bases are the same. So we have 8 minus 3, so we have x to the 5. But when we have anything divided by itself, that does equal 1. But let's subtract. So we have 5 minus 5 is 0. And because anything that's divided by itself is equal to 1, then this exponent of 0 has to equal 1. So here's a helpful hint. Circle the term with the 0 power and put a 1 to help you. So this one's easy. It's the only one that is to the 0 power, so that does equal 1. But this one, it's only the y that's to the 0 power, so we're going to put a 1. So 15 times x to the 4th times 1 is just 15x to the 4th. And then remember, this whole thing here is to the 0 power, so that is just 1. And then this here, only the x is to the 0 power, so we'll put 1. 9 times 1 times y to the 7 gives you 9y to the 7. So that is my presentation, and I thank you so much for your time and this possible opportunity.